Hello students, I hope all you are doing well. I am Vinith. I'm your senior faculty, senior chemistry teacher, chemical reactions and equations, topics covered. Okay, what are the topics we are going to cover in this session? So first, basics. We are going to cover the basics. We are going to cover the basics. Basics are very important. Without the basics, you cannot write the chemical equation, cannot balance the chemical equation. Okay. Next, writing and balancing the chemical equation, symbols, physical states, types of chemical reactions, activity with activities. Okay, types of chemical reaction with the activities. Okay. Next, in text questions. Okay, in the middle of the textbook there are some questions, and also at last we have some questions. So I will explain the middle questions. That means in between the topics there are some questions. I'll explain that questions also, and also in text question the last question. And there is another facility, that is nothing but comment section. You can use the comment section. From the comment section I will try to clear your doubts. Okay, yes. Next, effects of oxidation. Last is summary. Okay, nice. So let me go into the topic. First is basics. In the basics, what are the major things you should know in the basics? Okay, first is electronic configuration. Electronic configuration is nothing but electrons distribution in the shells, and valency, the combining capacity, cations and anions, and the method used to write the formula from the given word formula. Okay, so this is the method called crisscross method. Yes. So first topic in the basics is electronic configuration. What is electronic configuration? What are the shells? What is atom actually? So atom is an indivisible particle of a matter. Okay, it is atom. Atom consists of a nucleus and surrounded with the orbits. In the orbits, the electrons are revolving. Okay, let me repeat once again. So atom consists of nucleus. This is a nucleus that consists of a shells, K element shell. Okay, K element shells was introduced by the scientist called Niels Bohr. Okay, is a scientist Niels Bohr. So what are the shells? It's already given, that is nothing but K, L, M, and shells. Okay, so K, L, M, and shells. Number of electrons can be filled in the respective shells K, L, M, N. So how many electrons can be filled? So in K shell we can fill 2 electrons, in L 8 electrons, in M 16 electrons, whereas 60, sorry, let me correct it, it's a 18 electrons, and in N 32 electrons. Okay, so in N 32 electrons, but this is the actual capacity of the shells. But what we want, the electronic configuration. Electronic configuration follows a rule called octet rule. It's a octet rule. What is octet rule? According to the octet rule, the atom will be in the stable state whenever there are 8 electrons or completely filled electrons in the outermost shell. Okay, so you can fill the electrons like this, 2 comma 8 comma 8 comma 8. Okay, so the students in the 10th grade should know 1 to 20 elements at least, but maximum 1 to 30 elements. Okay, with atomic number and atomic mass. Okay, yes. So we can take one example, magnesium. Why only magnesium? We can take another example also. Yes, we can take another example. First we will take the magnesium. Magnesium atomic number. What is magnesium atomic number? 12. Magnesium atomic number is 12. So how can we fill the electrons in the K element shell? So there are 12 electrons. First fill 2 electrons completely filled, 2 in the K shell, and after that 8 electrons. Okay, now 2 plus 8, 10 electrons completely filled. Remaining 2 can be filled in the M shell. Here is the 2 electrons in the outermost shell. Okay, so in the outermost shell, and there is another rule. There is another rule to make the bonds. the outermost shell of an atom should be 8 electrons are completely filled. But here 2 electrons are there. If the electrons in the outermost shell are less than 4, you can give the electrons. If they are more than 4, you can take the electrons. The and 4 means it can give 4 electrons or it can take in electrons. So let me give an example how atom can give electrons or how atom can take electrons. So here magnesium, same magnesium only with atomic number 12, 2 comma 8 comma 2, right? And let oxygen, let me take an example. Oxygen atomic number 8, oxygen atomic number is 8 and the electronic configuration will be 2 comma 6. Okay, electronic configuration is 2 comma 6. If you see here, compare magnesium and oxygen. So in the outermost shell of the magnesium, how many electrons are there? Yes, 2 electrons. Okay, there are 2 electrons in the outermost shell of an magnesium, and in the oxygen there are 6 electrons. Okay, in the 6 electrons. So when there are less than 4 electrons, the atom will try to donate its electrons by becoming stable state, which is 8 electrons in the outermost shell. Whereas oxygen in the outermost shell having 6 electrons will try to take electrons to become stable. So more than 4 will take the electrons, less than 4 will give the electrons. So after giving 2 electrons, magnesium before magnesium will have 12 electrons and 12 protons. 12 electrons and 12 protons. After donating 2 electrons, the magnesium with 10 electrons, protons 12 protons. Magnesium with 10 electrons and 12 protons. So here always the electron number and proton number should be equal. So the extra 2 protons can be kept as a charge on the magnesium. So magnesium now it would be Mg plus 2. Mg plus 2. And oxygen with outermost shell electron 6 will take the 2 electrons. After taking 2 electrons, before taking 2 electrons, the oxygen number of electrons will be 8 electrons and 8 protons. Okay, 8 electrons and 8 protons. After taking 2 electrons, number of electrons in the oxygen will be 10 electrons and protons will be 8. Same. So the extra 2 electrons can be kept as a charge on the oxygen. So now the oxygen charge will be oxygen with minus 2. Oxygen with minus 2. So what this plus charge indicates, what this minus charge indicates. So in next slide, valency. So valency is nothing but the charge of the atom. Charge of the atom means magnesium with plus 2 charge and oxygen with the minus 2 charge is nothing but the valency of an atom. So here valency refers to the combining capacity of the elements. So combining capacity. Magnesium can combine with minus 2 atoms or plus minus 1 atoms, 2 atoms. So there we can take one example, Cl minus, chlorine with the charge minus 1. So chlorine with the charge minus 1 have to combine with the magnesium, but we need 2 chlorines to combine with the magnesium because magnesium plus 2, chlorine is minus 1. We are not having same charge. So that's why to maintain same charge, we need 2 chlorines, so that minus 1 minus 2, this is plus 2. So to make bond between magnesium and chlorine, we need 1 magnesium, 2 chlorines. Okay. So this is how the valency. Okay. So valency is nothing but the valency refers to the combining capacity of the elements. Valency refers to the combining capacity of the elements. So here is the valency. So next we have cations and anions. What is the meaning of cations? Let me show an example with the diagram. Let us assume this is a beaker. Beaker contains two rods. They are called as electrodes because they are directly connected to the battery. So here is a solution. So longer terminal is nothing but the positive terminal. This shorter one is a negative. So this is a negative terminal. This is a positive terminal. Hope everybody can see the symbols. Yes, let me know in the comments. Yes, everybody can see the symbols. So this is the positive and this is the negative terminal of the battery. Okay, this is a battery. So directly to the battery, the positive terminal is connected to the positive. This will be positive, which is nothing but anode. And this is nothing but negative terminal. Negative electrode is called cathode. Cathode. So according to the physics and chemistry, we know that like poles repel each other, unlike poles attract. So let me know in the comments which charges move towards the cathode, which type of charges, plus charges or minus charges. Yes, yes, very good. So positive charges will move towards the cathode. Cathode is a negative terminal. This is a negative terminal. This is a positive terminal. So towards the negative terminal, positive charges will move. What are positive charges? Just now we have learned in the previous slides, that is magnesium plus 2 or sodium plus 1 or aluminum plus 3, and negative charges are oxygen minus 2, chlorine minus 1. Okay, these are the negative charges. Okay, so positive charges always tries to move towards the negative terminal, whereas negative charges will try to move towards the positive terminal. Okay, so these positive charges are moving towards the cathode. That's why these positive charges are called as cations. The ionic species which move towards the cathode are called as cations. The ionic species which move towards the anode are called as anions. Okay, this is how we named the cations and anions. Okay, so cations are nothing but the ions which move towards the cathode. Anions are the ions which move towards the anode. Okay, so hope you understand about the cations and anions. And here there is a definition called cations carry positive charge due to electron loss. Anions carry negative charge due to the electron gain. We already discussed this thing in the previous slide, that is nothing but the valency and the electronic configuration. Okay, hope you understand about the cations and anions. Okay, next, this is a crisscross method. What is the crisscross method? Let me tell you with an example. uh, Sodium hydroxide. Sodium, sorry. Uh, Let me write in the form of words, because we want to write the formula with the given word form of the formula. So here sodium hydroxide. Sodium hydroxide. We know sodium is Na, hydroxide is OH. Sodium charge. What is the sodium charge? Let me know in the comments. Yes, plus 1. This is plus 1 and this is hydroxide is minus 1. So plus 1 minus 1 get cancelled each other, and when they want to make bond with itself, Na will be one time and OH will be one time NaOH. NaOH is nothing but the sodium hydroxide. So the given word form of the formula can be written in the form of molecular formula with the help of crisscross method. Let me take another example. Another example, let me know in the comments. Fast. Yes, aluminum chloride. Aluminum chloride. Aluminum chloride. So aluminum. Okay, what is aluminum? Aluminum charge. Aluminum charge is plus 3. Very good. Okay, aluminum charges plus 3, whereas chlorine charges minus 1. So here the charges are not same. Here plus 3, minus 1. So how can they make the bond? So here is the method called crisscross method. Crisscross method means the charge of the aluminum should be equal to the number of chlorine. The charge of the chlorine should be equal to the number of aluminum. So chlorine charge is 1, which means we need to take only one aluminum, and aluminum charge is 3, we need to take 3 chlorines. Finally, AlCl3 will be the aluminum trichloride formula. Aluminum chloride formula is AlCl3. This is how we will write the given word form of the formula in the form of molecular form. Okay, hope you understand. This is how they will ask in the exam. They'll give you the word form of the chemical reaction. You have to write it in the form of molecular form of the reaction and equation, and you have to balance the equation. Okay, hope you understand the crisscross method. So this is what the basics. So next we are moving into the writing and balancing the chemical reaction. One example, hydrogen plus chlorine gives hydrogen chloride. So hydrogen, normally hydrogen exists in the form of H2 plus chlorine exists in the form of Cl2, gives hydrogen chloride. Hydrogen charges plus 1, chlorine charges minus 1. Plus 1 minus 1 get cancelled, and the formula is HCl. HCl. Number of hydrogens in the LHS, left hand side. Okay, number of hydrogens in the RHS. Just compare them. Okay, 2 hydrogens, 2 chlorines, and here 1 hydrogen, 1 chlorine. Just keep 2 here. Now it is balanced. Balanced form of the chemical equation. Okay. Next, barium chloride plus aluminum sulfate gives barium sulfate plus aluminum chloride. Okay. First, barium chloride. Barium will be plus 2, chloride will be minus 1. Do the crisscross method. So then you can write the formula in the form of BaCl2 plus aluminum sulfate. Aluminum charges plus 3, sulfate charges minus 2. Plus 3 minus 2, crisscross method. Crisscross method. So plus 3 will come to the sulfate, minus 2 of the sulfate will goes to the aluminum. So now the aluminum will be 2 times, sulfate will be 3 times. Okay. So the products are barium sulfate. Barium sulfate is barium is plus 2, sulfate is minus 2. So then finally the formula will be BaSO4 plus aluminum chloride. So aluminum chloride means aluminum is plus 3, chloride is minus 1. So in previous slide we have already done it. So AlCl3. AlCl3. So count the number of barium here. So barium is 1 and 1. Sulfate is 3 times of sulfate, 1 time of sulfate here. So aluminum is 1 time here, 2, sorry, aluminum is 2 here, 1 time here. So now we have to balance the chlorines, sulfate and aluminum. Okay. So here there are 3 sulfates. You can make it 3 sulfate in the RHS by multiplying 3 over here. Okay, 3. So now the sulfates are balanced. Barium becomes 3 here. Now here only 1. So we will balance the barium. So when we are balancing barium, 3 2s are 6 chlorines are changed. The number of chlorines now are 3 2s are 6 here. Here only 3. So to make it 6, we have to multiply with 2. 2 3s are 6 chlorines. Here 6 chlorines. Barium's balanced, chlorines balanced, and sulfates also balanced. And finally, Al2, aluminums are 2 here, and here also 2. So finally, this is the balanced chemical reaction for the barium chloride and aluminum sulfate gives barium sulfate plus aluminum chloride. Okay, hope you understand the balancing chemical reaction. Next, we have another equation, that is sodium plus water. Sodium is nothing but Na plus water is H2O gives sodium hydroxide. What is the formula of sodium hydroxide? NaOH plus hydrogen. Hydrogen means in the reaction, always remember hydrogen is H2. Remember, hydrogen is H2. So hydrogen is H2 gas over here. So one sodium balanced. Hydrogens 2, 3 here. So whenever there is a 2 or 3, 3 and 2 are, this is even number and odd number. We cannot make the even number to odd number or odd number to even number. So just simply check whether we can change the even number, odd number, odd number to even number. Here 2, just multiply 2 here, 2 hydrogens, 4 hydrogens, 4 hydrogens. Now just multiply 2 here, now the hydrogens are 4. So hydrogens balanced, 2 into oxygen, 2 oxygens, 2 oxygens balanced, 2 into sodium, 2 sodium, 1 sodium, just keep 2 here, now it is balanced form of the chemical equation of the sodium and water gives sodium hydroxide plus hydrogen gas. Okay. Hope you understand the balancing chemical equation. This method is called trial and error method. Trial and error method. Why it is called as trial and error method? We are trialing first. We are doing. If there is any error, we have to again check the number of atoms in the LHS, in the RHS. Then you can proceed with the trial again. Okay. So next, what is the topic here? Writing the symbols. Okay. This is a normal form of the equation. Okay. Normal form of the equation. Then here they have mentioned S, G, S, and here also AQ, 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 liquid, and here solid, aqueous, aqueous, gas. Okay. What are this physical state? You have to mention the physical state. Mostly they won't ask you to write the physical state of the equations. Okay. What are these terms? Okay. Solid, S is nothing but solid, G is nothing but gaseous, we know, and L is liquid. So we know this three. But what is the meaning of AQ? AQ is aqueous. Whenever there is a solid mixed in the water is called aqueous. Let us assume NaCl, NaCl, AQ. That means NaCl is a common salt which is in the solid state at a room temperature. But when you add it in the water, it dissolves in the water. That liquid is nothing but the aqueous solution of the NaCl. NaCl, aqueous means the solid mixed in the water which is in the liquid state. Okay. Hope you understand the physical states of the given chemicals. Next, writing and balancing chemical equation. Okay, there is another question about the writing and balancing chemical equation. This is from the textbook. Okay, just go through the textbook. You can find this question in the textbook. Okay, solution of the barium chloride and sodium sulfate in water react to give insoluble barium sulfate and the solution of sodium chloride. So how can we write the barium chloride? With the basics. What is electronic configuration, valency, cations and anions, and last is crisscross method. So with the help of crisscross method, you can able to write the barium chloride formula. Barium chloride BaCl2 plus sodium sulfate. Sodium is +1, sulfate is -2. Crisscross, sodium will be 2 times and sulfate will be single. So here and the products are barium sulfate and the sodium chloride. Barium sulfate is BaSO4 plus sodium chloride. Sodium chloride is a common salt NaCl. So they'll ask you like this in the form of equation or a question. You have to write it in the form of equation. Then you have to balance with the method called trial and error. So trial and error, barium chloride, Na2SO4, sodium sulfate. Here bariums are 1 barium, 1 barium balanced, 2 chlorines, 1 chlorine, 2 sodiums, 1 sodium. So we have to balance only sodium and chloride in the RHS. So in the right answer, just keep 2. Now it is balanced chemical equation form of the given equation. Okay. Hope you understand the balancing chemical equation with the given question. Okay. Next. Sodium hydroxide solution reacts with hydrochloric acid. Sodium hydroxide is NaOH plus hydrochloric acid is HCl, HCl gives Gives what? Gives produces sodium chloride solution with water. Sodium chloride solution is NaCl plus water is H2O. Okay, H2O. Say, check here, number of sodiums are equal in the RHS and LHS. OH, uh, two hydrogen, two hydrogens, one oxygen, and what is there? Chlorine. I think it is balanced equation. Yes, it is a balanced equation. Sometimes they will confuse you by giving this type of questions. They'll ask you to write it in the form of equation and also balance it. But don't get confused. Just see the question and write it in the form of equation. Just count the number of atoms in the LHS and RHS. If they are equal, don't need to balance it. Now it is already balanced. Okay. Next. Yes. So now the actual topic, we are going into the actual topic. What is the actual topic? Okay. So here there are different types of reactions in day-to-day life, but in this unit we will try to understand this reaction with the help of activities given in the textbook. So first reaction is combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and last reaction, which is a oxidation and reduction reaction. So first reaction is the combination reaction. So what is combination reaction? What are the activities involved in the combination reaction? We will discuss now. Okay. Yes. So this is the definition for the combination reaction, and the general representation for the combination reaction is A plus B gives AB. A plus B gives AB. So when there are two reactants reacting together or combining together to give single product is nothing but the combination reaction. Okay. The general representation of the combination reaction is A plus B gives AB. Okay. Let me repeat once again. Combination reaction is nothing but two reactants react together or two reactants combine together to give one product is nothing but the combination reaction. The general representation is A plus B gives AB. Okay. Combination reaction. So combination reaction with the example activity 1.4, that is quicklime versus water. What are the materials required for this experiment? So see, always remember in this session we will try to understand the type of reaction with the activities. Okay, that the activities are nothing but from the NCERT textbook. Okay, just go through the textbook once again so that you will understand very clearly. Okay, first, what are the materials required or apparatus required for this activity 1.4? That is calcium oxide. The calcium oxide formula is CaO. It's also called as quicklime, distilled water, beakers, glass rods, and litmus paper. What is the need of litmus paper? To check the acidity or basicity of the solution, we need litmus paper. So we don't need to check the litmus paper test. Actually in the textbook they have not mentioned the litmus. We can use the litmus paper for the acidity and the basicity. Okay, next, the procedure. So the procedure is very simple. Take calcium oxide in a beaker, just add the water. So you can able to hear the sound, steam sound or hissing sound. That is nothing but the heat is liberating from the reactions vessel. Okay, so the reaction, what is the reaction actually happening in the reaction vessel? So here is the reaction vessel with the calcium oxide. It's a quicklime. When you add the water, you can able to hear the sound, that is the hissing sound or steam coming out of the reaction vessel. That is nothing but the heat is coming out of the vessel. So calcium oxide solid when is mixed with the water, it gives calcium hydroxide plus heat. Okay, calcium oxide when it mixed with the water gives calcium hydroxide plus heat. This is called the combination reaction. Combination reaction means two reactants react together, gives one product, is the combination reaction. And we have extra thing, that is heat is liberating out. This is also called as exothermic reaction. Okay, what is exothermic reaction? The reaction which releases the heat is nothing but the exothermic reaction. And the reaction which takes the heat or absorbs the heat is nothing but the endothermic reaction. Okay, so this is the combination reaction and a exothermic reaction. Okay, hope you understand the combination reaction with the given activity. Okay, next, combination reaction examples. So here carbon plus oxygen gives carbon dioxide, one example. Second example is hydrogen plus oxygen gives water. Okay, this is another example. This both won't follow the combination reaction, but they comes under the combination reaction. Okay, so these are the examples of the combination reaction. Next, decomposition reaction. Okay, this is the second type of the reaction after completing first combination reaction. This is the second type of reaction, that is decomposition reaction. So what is decomposition reaction actually? So in day to day life we heard about the word called decomposition. What is decomposition? Okay, whenever a animal dies, so it starts decomposing. A bad smell comes out of the dead body of the animal. Okay, that is nothing but the body is getting breakdown. Okay, the body cells are getting breakdown. That is nothing but the decomposition. So decomposition means breaking down of the particles is nothing but the decomposition. So what is the definition of the decomposition? So definition of the decomposition is in the compound of, I mean, a single compound reactant breaks down into two or more products is nothing but the decomposition reaction. Okay, let me repeat once again. So single reactants gives two or more products is nothing but the decomposition reaction, and this is the reverse reaction for the combination reaction, opposite reaction for the combination reaction. What is so here AB breaks down into A plus B. So this will be the reverse reaction of the combination reaction. Okay, decomposition reaction which gives a simpler substances that are products with the major substance, that is a single product, single compound reactant gives more than two products. Okay, decomposition. So let us understand the decomposition with the activities, in text activities. Activity 1.5, heating of the ferrous sulfate. Heating of the ferrous sulfate. The materials required for the ferrous sulfate. Ferrous sulfate requires FeSO4 plus 7H2. This is the water in crystalline form. Actual formula is FeSO4. Then what is the need of H2? FeSO4 is the ferrous sulfate. But what is the use of the H2? So in some chemicals, the water molecule will be in the molecular formula. That is nothing but water in crystallization. Okay, water in crystallization. So water will be already in the chemical formula. And hard glass tubes, hard glass test tube. Why we are taking hard glass tubes? Because we are dealing with the heat. Okay, test tube holder is very mandatory. Without the test tube holder, you cannot hold it with your bare hands. Okay, next, Bunsen burner for the heat. Okay, next, so procedure. So what is the procedure? Just take the ferrous sulfate chemical in the test tube, hold it with the holder and heat it under the Bunsen burner. So what will be the observation? So observe color change of the solid. Observe color change of the solid. Here, and there is a precautionary thing is, you never keep the test tube towards your face. It should be slanting position, which is away from your face. Okay, because the harmful gases are releasing from the chemical, the experiment. Okay, so hold it with the test tube holder and heat it under the Bunsen burner. So what are the observation you can find? So before the reaction, there is some water molecules in the ferrous sulfate. Okay, so water molecules, to remove the water molecules, just gently heat the ferrous sulfate. The ferrous sulfate, from the ferrous sulfate, the steam is coming out. So that steam is called water in crystallization. After removing the steam, 7 aqua molecules, now it will be FeSO4 Okay, now we want FeSO4 to heat strongly. Okay, that FeSO4 when on heating gives Fe2O3 and SO2SO3. This is Fe2O3 is nothing but ferric oxide, and this is sulfur dioxide and sulfur trioxide. So these are the observation you can find. So and also ferrous sulfate will be in green color. Remember, it is green color, but now it changes to reddish brown. Why it is reddish brown? Because always remember Fe2O3 is a chemical formula that you can find it in the corrosion, rusting. So this will be reddish brown. Reddish brown. These gases will come out of the. So what are the observations you can find in this experiment? Color will be changed and the some gases are releasing. That gases are nothing but SO2 and SO3. Okay, this is the decomposition. In decomposition we have three types of decomposition. This is thermal decomposition. This is thermal decomposition. Thermal decomposition means with the help of heat we will decompose the chemical compound. So decomposition with the help of heat is nothing but thermal decomposition. Next reaction is the same decomposition reaction with the activity 1.6, that is heating of the lead nitrate. Same lead nitrate, in the place of FeSO4 we are taking lead nitrate. So when lead nitrate heated, what are the materials required we want? Same lead nitrate, test tube holder, Bunsen. The procedure will be same. So when you heat the lead nitrate, it gives PbO, lead oxide, and nitrogen dioxide and oxygen. So this is also the one type of reaction for the decomposition reaction. Okay, so this is the decomposition reaction. Which type of decomposition reaction? Let me know in the comments. Yes, this is thermal decomposition because there is a heat over here. Okay, thermal decomposition. Okay, initially it was white crystals. Okay, note its initial color will be white. So heat the test tube and then strongly. So what are the observation you will find? So there will be a change in color. There will be a change in color and some gases will be released out of the reaction vessel. Okay, this is what the decomposition reaction activity 1.6, heating of lead nitrate. Next, decomposition reaction activity 1.7. So what is decomposition reaction? What is activity 1.7? Electrolysis of water. Electrolysis water. So what is electrolysis? So while explaining cations and anions, I have drawn a beaker with the two terminals which is connected to the battery. That is nothing but the electrolysis setup. So the two electrodes dipped in the solution called electrolyte. So electrolyte when will divides into positive and negative ions when it is connected with the battery. Okay, when it is connected with the battery, the solution which is called as electrolyte will divides into positive ions and negative ions. That movement of positive ions towards the negative terminal, negative ions towards the positive terminal is nothing but the electrolysis. So we are doing the electrolysis of the water, which is the acidified water. So the materials required. So we need Volt-Hoffmann apparatus of a plastic through with two test tube inverted, which over a graphite metal or graphite or metallic rods, electrodes, and acidified water, and finally it's a power supply, DC power supply. So the procedure. So what will be the procedure? So you can see it in the diagram. So two test tubes are inverted. They are connected with the electrodes, and this electrode is called negative terminal. This will be the positive terminal. Negative terminal is called as, what is negative terminal? This negative terminal is called as cathode, and this positive terminal is called anode. Okay, sorry, anode. Negative terminal is called cathode, positive terminal is called as anode. So anode and cathode and anode. So in this water, so when water divides, it gives H plus and OH minus. OH plus and OH minus. So H plus will move towards the cathode, OH minus will move towards the anode. Okay, so this H plus, when they combine together, H plus gives H2 hydrogen gas, and the OH. Okay, from the OH also the hydrogen is removed and it is donated to the hydrogen. The actual reaction is H2O gives O2 plus 4H plus 4 electrons. So this 4H is nothing but 2H2 and oxygen. So oxygen from the OH, O2. So H2, 2H2 will be collected where? It will be collected at cathode and O2 will be collected at anode, because hydrogens are positive charges, they move towards the negative terminal cathode. So negative terminal you will hydrogen will be collected, and positive terminal anode oxygen is collected. So this is what the decomposition of water activity 1.7, which is a electrolysis of the water. Electrolysis of the water, let me repeat once again, this is the electrical equipment which is connected to the battery. Here two electrodes, cathode and anode. At cathode hydrogen gas is collected, at anode oxygen is collected. This type of decomposition is called electrolytic decomposition. Okay, this is called electrolytic decomposition. Lytic decomposition. Electrolytic decomposition. There are three types of decomposition. First one is thermal decomposition. Second one is electrolytic decomposition, and last third one is photolytic decomposition. Photolytic decomposition means in the presence of sunlight. So there is another activity called silver chloride in the presence of sunlight. Activity 1.8. So what is this activity? What are the materials required for this? Silver chloride. Silver chloride formula AgCl, and watch glass, which is nothing, which we can take petri dish also, and we need sunlight. If there is no sunlight, we can take sodium lamp. Okay, we can take sodium lamp. So AgCl, okay, AgCl, when it is this is the procedure. Okay, AgCl, when it is kept in the petri dish or the watch glass, when it is kept in the sunlight, so it starts its reaction. What is the reaction? This reaction is called photolytic decomposition. AgCl will be decomposed into Ag and Cl in the presence of sunlight. So there will be a change in color. So initially it was some color, it changed white color. Before the reaction, before the decomposition, white crystals change into gray silver. Why? Because AgCl decomposed into Ag, which is a silver in color, and Cl2 gas is liberated out. Okay, Cl2 gas is liberated out. So this is what the reaction of silver chloride in the presence of sunlight. So this is the observation. What type of reaction is this? Let me know in the comments. Yes, it's a photolytic decomposition reaction. First one is thermal decomposition, electrical decomposition second one, and third one is photolytic decomposition. Okay, so these are the types of decompositions. Next, in-text exercises. So what is this in-text exercises? In the middle of the topic, there are some questions in your NCERT textbook. So a solution of substance X is used for whitewashing. A solution of substance which is X used for whitewashing. Whitewashing means which is nothing but the calcium oxide. Calcium oxide. Okay, this is calcium oxide. Whitewashing. Name the substance X. This is the name X. Write its formula. Calcium oxide. Write the reaction of the substance X and name in the above reaction with the water. So CaO, when it reacts with the H2O, gives what? Let me know in the comments. Yes, it is a type of combination reaction. It gives calcium hydroxide plus heat. Exothermic combination reaction. Okay. This is what the in-text questions. Okay. Summary of this topic. So finally, summary of this topic. Only summary of this session till decomposition reaction. Till decomposition reaction. Basics we have done. Writing and balancing reactions. Symbols. Types of reactions. Only how many types of reaction? Combination and decomposition with activities. And activities also we have done in text exercises. Okay. Types of the chemical reaction with the examples. Types of the reactions with the chemical examples and activities and in text questions. and also the effects of oxidation reaction in our everyday life. Okay, effects of oxidation in our everyday life, and it's a summary after the completing all the in-text questions and the topics. Okay, so let me go into the topic. So it's a third type of reaction, which is nothing but the displacement reaction. What is displacement reaction? The definition of the displacement reaction is very simple. So here what happens, the more reactive metal displaces the less reactive metal from the salt, and it gives a new compound. So it's a general representation. A when reacts with BC, let us assume A is high reactive metal which displaces B from BC salt. So it gives AC plus B alone. Okay, this is called the displacement reaction. It's a single displacement reaction. Okay, only single metal is being displaced by the other more, high reactive metal is displacing the metal from the salt. Okay, this is what the single displacement reaction means. Okay, so it is also called a single replacement or substitution reaction. Single replacement or substitution reaction. So the activity for this reaction, okay, there is an activity in our textbook. So here the iron nails dipped in the copper sulfate. So iron nails dipped in the copper sulfate. So that is nothing but we need the materials for this experiment are iron nails, copper sulfate, and two test tubes. So the procedure, okay, take two test tubes. In one test tube, just take the copper sulfate solution and keep it aside. Okay, and in the another test tube, take copper sulfate solution and dip a iron nail in it. Dip a iron nail in it and keep it aside for 20 to 30 minutes. Okay, so unless and until you, if you find any color change, you have to keep it till 30 to 20 minutes. Okay, 20 to 30 minutes is enough. So after finding a color change, just compare the two solution, normal copper sulfate, pure copper sulfate solution, and the copper sulfate solution with the iron nail dip. So what is the difference? Here the observations are, so blue color copper sulfates changed into green color in which the iron nail is dipped. But whereas copper sulfate, pure form of the copper sulfate will be same blue in color. So copper sulfate, when iron nail is dipped in the copper sulfate, iron is high reactive which displaces the copper. It gives iron sulfate plus copper. So initially it was blue in color, whereas iron sulfate will be now with the iron sulfate green color. Okay, the color changes and the reaction is called single displacement reaction. This is what the example for this single displacement reaction. So let me repeat once again. Two test tubes. One test tube contains copper sulfate. Keep it aside. Why we are keeping aside? Because we have to compare the solution with this actual reaction vessel. Okay, so in this the copper sulfate with the iron nail dipped. So when you compare this both, so after 20 minutes, this the color change, you can find the color change in the copper sulfate dipped in the iron sulfate. Iron nail. So why this type of change? This is called the single displacement reaction. When high reactive metal placed in the low reactive salt, it changes, the metal high reactive displaces the low reactive. This is nothing but the displacement reaction. This is the activity for that single displacement reaction. Okay, hope you understand this single displacement reaction with the given activity 1.9. Okay, the examples are zinc is a high reactive which displaces copper. It gives copper, zinc sulfate plus copper, and lead, which is high reactive than the copper, gives lead chloride with copper. Okay, these are the example for the single displacement reaction. Okay, so next is a double displacement reaction. What will be the double displacement reaction? So single displacement means only single metal is displacing, whereas in double displacement two metals displace each other. Not only two metals, two ions, that are cations and anions. Okay, one cation displaces other cation, and that cation will go and attack with the another anion. So AC, the general representation will be AC plus CD gives AD plus CB. So the reaction for this, okay, the reaction or activity for this displacement reaction. So what is the definition actually? Okay, a double displacement reaction is a chemical reaction in which positive and negative ions will exchange each other, will exchange their partners to form two new compounds. Okay, that is nothing but the double displacement reaction. So the activity 1.10, 1.10, which is sodium sulfate reaction with the barium chloride, and the materials required for this, the chemicals and two test tubes. Okay, take two test tubes. The procedure: take two test tubes. In one test tube, take barium chloride solution. In another test tube, take sodium sulfate. Just mix together. What are the observation you will find? Okay, when you mix the sodium sulfate with the barium chloride, it gives, the reaction is barium chloride when it reacts with the sodium Na2SO4, it gives barium sulfate. This goes and attack with this, and this attacks with this, and gives NaCl. Okay, NaCl. So this is the insoluble salt formed which does not dissolve in the water, barium sulfate. This reaction is also called as precipitation reaction because it gives a precipitate. Precipitate is nothing but, precipitate is represented as downward arrow mark. So downward arrow mark means which comes to the bottom of the reaction vessel. Okay, this is a barium sulfate. So barium sulfate does not dissolve in the water. You can find the observation, that is here barium sulfate is collected at the bottom. So it goes down to the reaction vessel. So this is the representation of the double displacement reaction with the activity 1.10. This is double displacement reaction. Okay, this is so due to, see, mixing when both reactants colorless solution turning milky white upon mixing barium sulfate. So barium sulfate is due to, barium sulfate is an insoluble salt which goes to the bottom of the reaction vessel. Okay, hope you understand the double displacement with an activity 1.10. So next, oxidation and reduction. What is oxidation and reduction? There are two definitions. First, let me explain oxidation. Oxidation is nothing but addition of oxygen or removal of hydrogen. So in terms of hydrogen and oxygen, so when oxygen is added to the reaction or hydrogen is removed is called oxidation. And reduction means addition of hydrogen and removal of oxygen, vice versa. So oxidation means addition of oxygen, removal of hydrogen, and reduction means addition of hydrogen, removal of oxygen. Okay, hope you understand. Okay, this is what the definition of the oxidation and reduction. These are the last reaction of the types of reaction. So the materials required for this experiment which explains the oxidation and reduction. Okay, what is it? Heating of an copper. For that we need copper foil, Bunsen burner, and heat resistant mat, safety goggles. Safety, why we want safety goggles? We are dealing with the heat, that's why we have to wear the safety goggles, because in our body panchendriyanam nayanam pradhanam. Panchendriyanam nayanam pradhanam means eyes are very important for our body. Without eyes we cannot live. Yes, we can able to live, but it's very difficult. Okay, so safety goggles is mandatory. So procedure, just take the copper and hold it, or you can just keep it in the petri dish or any dish. Directly use the burner, or else you can hold the copper plate or copper wire with the holder and heat it under the Bunsen burner. So after the reaction, you can find a black color coating on the copper. That black color coating is nothing but copper oxide. Copper oxide is CuO. CuO, which is in the black color. So copper, when reacts with oxygen in the atmosphere, combustion reaction. Remember, combustion reaction is addition of oxygen. So copper, when it is heated in the presence of oxygen, it gives copper oxide. Black color coating is copper oxide, and the metal is copper. Copper, see, metal does not completely change its color. Only outer part coating will be black in color. That outer coating will be copper oxide. Okay. Yes. This is what the oxidation reaction. Oxidation means addition of oxygen. So this is addition of oxygen. Now we have to understand what is reduction with the same reaction. So copper oxide formed in that reaction collected, that black color powder is collected, and that black color powder treated with the hydrogen gas. So copper oxide, when it reacts with hydrogen gas, so what are the observations? Okay, what are the observations? So hydrogen always tries to react with the oxygen. So H2O, it gives copper plus H2O. Copper plus H2O. So addition of hydrogen is nothing but the reduction. Addition of hydrogen is nothing but the reduction. So here what happens? Hydrogen is added to the copper oxide. So hydrogen is added to the copper oxide or removal of oxygen. So this copper oxide, from the copper oxide, the oxygen is being removed. This is nothing but the copper oxide is getting reduced. Getting reduced means the copper oxide is undergoing the reduction reaction, whereas hydrogen H2O, hydrogen H2 is undergoing the oxidation reaction. Oxygen from the copper oxide is added to the hydrogen. It gives H2O. This is getting oxidized. Okay. The reaction in which the oxidation and reduction simultaneously occurs is nothing but a redox reaction. Redox reaction. Red means reduction, ox means oxidation. Redox reaction. This is what the redox reaction. Okay. Next. Okay, effects of oxidation in our everyday life. So where can we find the oxidation effect? So oxidation advantages we have, disadvantages also we have. So these are the disadvantages of the oxidation: corrosion and rancidity. So first let me explain about the corrosion. What is corrosion? So corrosion is also called as rusting. Okay, rusting of, let us take an example, rusting of an iron. So when iron is exposed to the atmospheric gases, it get degraded, or the metal get destructed, I mean damaged. So the corrosion is a gradual destruction of a metal in the presence of air, moisture and other chemicals present in the atmosphere. So this is what the chemical representation of the corrosion. When iron reacts with oxygen in the presence of water molecule, it gives Fe2O3 plus H2O. This is called hydrated. Hydrated with the water molecule, it is called hydrated ferric oxide. What is ferric and what is ferrous? Ferric means Fe plus 3, ferrous means Fe plus 2. If the charge of the iron is plus 3, then it is called ferric. If the charge of the iron is plus 2, it is called ferrous. Okay. Hope you understand the corrosion definition. Let me repeat once again. The gradual destruction of the metals, which is iron, when it is exposed to the atmospheric gases, is called corrosion. So this is the first disadvantages of the oxidation. Okay. Next, rancidity. So what is rancidity? So oils or fats, when they expose to the air, they get rancid. What is rancid? They change their smell and taste. So we cannot eat them. The oil foods, we cannot eat them which are exposed to the air. Okay. That's why to prevent the rancidity, we fill the chips packets with the nitrogen gas, which prevents the rancidity of the food, oil foods. Okay. So this is called inert gas. Inert gas means that won't react with the food. Okay. So rancidity is the slow oxidation of a fat and oil foods, causing unpleasant smell and taste, change in taste. That's why we cannot eat them. Okay. This is what the rancidity definition. Okay. So pure oil, fresh oil converts to rancid oil when it is exposed to the air. Okay. So you should not keep the oil foods exposed to the air. It should be packed in the any of the container, airtight container. NCERT textbook questions, last questions. So first question, what is the first question? Which of the statements above reaction below are correct? Okay. So lead oxide, when it reacted with the carbon, it gives lead plus carbon dioxide. Okay. The options they have given: lead is getting reduced, carbon dioxide is getting oxidized, carbon is getting oxidized, lead oxide is getting reduced. So what will be the options? Okay, see, lead oxide is converting into lead. Okay, lead oxide is getting converted to, so from the lead oxide oxygen is being removed. So this is nothing but the reduction of lead. Okay, so reduction of lead, where you can find the reduction of lead? Lead is getting reduced. So lead is getting reduced will be the reduction, and lead oxide is getting reduced. So did you find any okay, sorry, lead is getting reduced. So first, and carbon is getting oxidized. Where is carbon is getting oxidized? A and C. Option 2 will be the correct answer. Okay. Next. So iron oxide reacting with the aluminum gives aluminum oxide plus iron. So what type of reaction is this? What type of reaction is this? Let me know in the comments. Yes, it's a single displacement reaction. So aluminum displaces the iron from the oxide, it gives aluminum oxide plus iron. This is single displacement reaction. Okay. Next, what happens when dilute hydrochloric acid is added to the iron fillings? So dilute hydrochloric acid, HCl plus iron gives HCl plus iron gives iron displaces the hydrogen, it gives FeCl2 or FeCl3 plus hydrogen gas H2. So iron's chloride salt with the hydrogen gas. Where is the iron chloride salt? Iron chloride with hydrogen gas. Option A is correct. Option A is correct. Next, what is balanced chemical equation? Why should chemical equation should be balanced? See, we know that in universe mass is neither be created nor be destroyed. So here from the reactants it should be converted to products. So reactant side and product side it should be balanced. That is why we should balance the reaction. Balanced chemical reaction means when the reactants and products are equal proportional, then it is called as balanced chemical reaction. We should balance the chemical reaction because according to the law of conservation of mass. Okay. Yes. Next, balance the chemical equations. So how can we balance the chemical equation? We can balance here only, here itself. Yes. Hydrogens here are one hydrogen, two hydrogens, three hydrogens, here two hydrogens. So how can we balance this? So and also there are three nitrate, one nitrate here, two nitrates. First we will balance the nitrate. Just keep two here, two nitrates, two NO3, two NO3 balanced. Hydrogens, two hydrogens, two hydrogens, four hydrogens. But here two hydrogens. So just multiply with 2, 2 2s are 4, 4 hydrogens, and oxygens are 2 oxygens. Don't count this nitrates. Nitrates are already balanced. Okay, 2 oxygens, 2 into oxygen, 2 oxygen, calcium 1, calcium 1. So everything was balanced. Okay, next. Here, sodium 1 sodium, 2 sodiums. Okay, oxygen 1 oxygen. Don't check with the sulfate SO4, here SO4 already balanced. Okay, don't need to disturb. So two hydrogens, oxygens are not balanced, sodiums are not balanced first. Okay, just keep two here, two sodiums, two into oxygen, two oxygen. Here not two oxygen, just multiply two, it becomes two oxygen. Hydrogens, two into hydrogen, two hydrogens, two hydrogens, four hydrogens, four hydrogens. Sulfate SO4 1, SO4 1. So now it is completely balanced. This is the balanced chemical equation for this reaction. Next, NaCl. NaCl plus AgNO3 gives AgCl plus NO. So if you count the number of atoms in the LHS and the RHS, they are equal in proportion. This is already balanced. You don't need to balance the equation. Next, last, BaCl2 plus H2SO4 gives BaSO4 plus HCl. So here, barium is balanced, sulfate is balanced, hydrogen and chlorine should be balanced in the RHS. Just keep two here. Now it is balanced reactions. So this is how we will balance the reaction. We already done in the previous slides before the 10 minutes break. That is the balancing and writing the reaction. So that is the method called trial and error method. Okay. Next. So write the balanced equation for the following reactions. So for the following reaction, calcium hydroxide plus carbon dioxide, calcium hydroxide plus carbon dioxide is CO2, gives calcium carbonate CaCO3 plus hydrogen with water. Water is H2O. So this is how we will write the equation form. Just balance this reaction and post it in the comment section. Let me know the answer. Okay. Students, I have already written in the form of equation. Just copy down this equation and balance the reaction and post it in the comments. Okay. Use the comment section, students. Yes. Next, zinc plus silver nitrate gives zinc nitrate plus silver. Zinc plus silver nitrate is AgNO3, gives zinc nitrate. Zinc charge is plus 2, nitrate charge is minus 1. Plus 2 minus 1 means nitrate should be 2 times. 2 times plus silver. Silver is Ag. So this is the representation of the word form of the equation in chemical formula. You just need to balance this. Okay, balance this and post it in the comments. This is the assessment. Okay, take it as an assessment. Next, aluminum plus copper chloride gives aluminum chloride plus copper. Okay, aluminum plus copper chloride CuCl2 gives AlCl3. Aluminum chloride means aluminum charges plus 3, chlorine charges minus 1. Crisscross AlCl3 gives plus copper. So this is the representation of the word form of the reaction in the molecular form. Next, barium chloride plus potassium sulfate gives barium sulfate plus potassium chloride. So barium chloride BaCl2 plus potassium sulfate. Potassium sulfate is potassium charges plus 1, sulfate charges minus 2. Plus 1 minus 2 crisscross K2SO4 gives BaSO4, barium sulfate plus KCl, potassium chloride. Okay, potassium chloride. This is how we will write the word form of the chemical equation into chemical formula. Okay, next we have some more word form of the equation. You have to write it in the form of chemical formula. So let me write the equation. You have to balance and just post it in the comment section. Just to note down this, take a screenshot or note down and balance this and post it in the comment section. Okay, this one. So potassium bromide plus barium iodide. Potassium bromide KBr plus barium iodide. Barium iodide. Barium charges plus 2, iodide is minus 1, crisscross BaI2 gives potassium iodide. Potassium iodide means Ki plus barium bromide. Barium bromide is BaBr2. So this is how we will represent the reaction, balance and post it in the comments. Zinc carbonate gives ZnCO3 gives zinc oxide plus carbon dioxide. And also see, write this in the form of, balance this equation and also name the type of the reaction. This type is double displacement already. So single reactant is giving 2 or more products. That is which type of reaction it is. Let me know in the comment section. Let's say is a decomposition reaction. It's a decomposition reaction. Okay. Next, hydrogen plus chlorine, H2 plus Cl2 gives HCl, is another type of reaction. Next, magnesium plus hydrochloric acid, Mg plus HCl gives what? Magnesium chloride MgCl2 plus hydrogen gas H2. MgCl2 plus hydrogen gas H2. So this is how we will write the equation form. Just balance them and post it in the comments. Hope everybody will note down these equations and they will balance and post it in the comments. At least I should see 10 comments. Yes. Let me go into the other questions. Okay. you don't need to balance it now, you can balance it later and post it in the comments. I will definitely check the comment section. Okay, what does one mean by the exothermic and endothermic? Exothermic and endothermic means the reaction which releases the heat, the reaction which absorbs the heat. Means exothermic is the reaction which releases the heat, which liberates the heat. The reaction which absorbs the heat is called endothermic. Okay, with examples, there are many examples like heat liberating reactions are uh, that is combination reaction, calcium oxide reacting with water, and heat absorbing reactions are the reaction decomposition reaction. You can write the reaction which needs the heat. Okay, next, why respiration is called as exothermic? Just take your finger and keep it under your nose. When you breathe out, you can feel that hot air is coming out. So that is nothing but the heat is liberated from the respiration. So respiration comes under the exothermic reaction. Why decomposition reaction called as opposite to the combination reaction? Write equation for this reactions. Okay, reverse of reaction means when combination means two reactants react together give one product. Decomposition means reverse of this, one reactant gives two or more products. So we can write the reaction. So like one reaction, so copper plus oxygen, copper oxide. So when you again heat it, when you decompose it, when you the combination is called copper plus oxygen gives copper oxide. So reverse of that will be copper oxide turning into copper plus oxide. Okay, that is nothing but the reverse reaction of the combination reaction is decomposition. Decomposition opposite will be combination. Okay, next. So write one equation each for the decomposition reaction where energy is supplied in the form of heat, light and electricity. Yes, decomposition reaction is of how many types? Let me know in the comments. Yes, there are three types of decomposition. Heat decomposition is called thermal decomposition. Light decomposition is called photolytic decomposition reaction. Electricity means electrical decomposition. We have discussed three activities for this decomposition. You can write that examples for the each decomposition reaction. Okay, what is the difference between the displacement and the double displacement? Write the equation. Displacement and double displacement means single metal displaces the metal from the salt is called single displacement. When two metals, two ions are exchanging each other is called double displacement. Yes. In refining of silver, the recovery of silver from the silver nitrate. Silver nitrate is AgNO3 when it reacts with displacement by the copper metal. So copper metal. So copper is high reactive than the Ag. It displaces the Ag. It gives copper nitrate which is CuNO3 taken twice plus silver which is Ag. Okay, silver is it. This is how you will refine the silver nitrate and you will obtain the purest form of the silver from the silver nitrate with the reaction of copper. Okay, this type of reaction is single displacement reaction. Okay, next, in-text exercises. In-text exercises same. What do you mean by the precipitation reaction? The reaction which gives the precipitate BaSO4, that is single displacement. In the double displacement we have done this. Okay, that is nothing but precipitation reaction. Explain in terms of gain or loss of oxygen. Two examples, oxidation and reduction. Addition of oxygen is called oxidation. Removal of oxygen is called reduction. Addition of oxygen is called oxidation. Removal of oxygen is called oxidation. Removal of oxygen is called reduction. Okay, one example is nothing but copper when it is heated in the presence of oxygen, copper oxide. When copper oxide treated with the hydrogen gas gives copper plus water. Copper plus water is nothing but the reduction. Okay, so that example you can write it for the oxidation and reduction. Shiny brown element X heated in the presence of becomes black in the presence of air becomes black in color. So that is nothing but copper. Shiny brown means copper. When it is heated in the presence of oxygen, it gives copper oxide. That black color is nothing but copper oxide. Okay, that name of that element will be copper. Okay, next, why do we apply paints on the iron articles? Iron articles when they expose to the air They undergo which type of reaction? Yes, oxidation and corrosion. So to prevent from the corrosion, we have to paint on the iron article so that it should be prevented from the corrosion. Okay. Oil and fat containing food item flushed with the nitrogen gas. When I was explaining about the rancidity, I've already explained about the nitrogen. Nitrogen is a noble gas which is filled in the chips packet or oily foods so that it should be prevented from the rancidity. Okay. Explain the terms corrosion and rancidity. Slow degradation of the metal is called corrosion. Oils getting rancid in the presence of oxygen is called rancidity. Okay. So summary of this complete unit, complete session. So before 10 minutes, we have already completed till the combination reaction and decomposition reaction. After the session, we have completed the types of reactions and effects of oxidation with the activities and NCERT questions. So in this session, we have done with the types of reaction, activities, in-text exercises and effects of oxidation in our everyday life.